Okay, greetings guys, and welcome to another edition by iCampSA. In this edition, we're looking at grade 12 mathematics, and this will be an introduction to statistics. We'll focus on the 5-number summary, look at the whisker box, and this will be part 1. And what really this is essentially grade 11 revision if you observe carefully. So in order for us to get started, let's have a look at what is happening here. So what I have here is a report card. And if you observe carefully, you will see that this report card here is for grade 11. There's a question that I want to ask you, which is, let's focus on maths as an example, which is here. Okay, so let's make it bigger. And let's just focus on mathematics, which is maths lit here. So if you observe carefully, you will see that the learner got 44%. So you will see that the learner mark equals 44%. But then what I also need you to quickly note is the class mark. So if you observe carefully, you will see that the grade average is 46%. And the question which I want us to ask ourselves when we are looking at this is that, did everyone get 46%? Is this what the grade average means? And the simple answer to this question is no. Okay. So grade average does not mean everyone got 46%. What it means is that if they normalize the marks of the learners, on average, everyone gets 46%. And this here, guys, will become our introduction to statistics. So we need to understand what do we mean when we say grade average, and how does it tell us about the performance of learners. Okay. So in order to kickstart this, I'm going to start by looking at definitions of terms. But this here is one of the aspects where we use statistics. So maybe let's quickly have a look at uses of statistics. So what you should note is that statistics is used in a couple of industries or in many applications. And this can include in, let's say, as an example, in engineering and energy, because they use a lot of statistics to make predictions and to determine what they should do and how they should do designs. So let's say in engineering, then what you will need to understand is also that it is used in finance when people want to make projections. So statistics from previous data is very useful. So it is also useful in businesses. They also use statistics. You'll also see that even in sports analytics, they also use statistics to look at a team and how it has been performing, and therefore how it is more likely to perform for certain, games. And you will also remember, in our case, even the IEC, we are looking at voting. They do a lot of statistics there. You will remember we have a body that we call StatsSA, where it will use statistics to be able to tell us a variety of things that are happening. What is the unemployment rate? How many people are educated? And so on and so forth. So these are but a few of the applications of statistics. Okay. Now that we are done with this, we'll go and start looking at what we call important terms. So for important terms, let's start out by this term here, which is called data. Okay. So data is just information or a piece of information which is collected for us to perform an analysis. So the next important term that we need to look at is population. It's very important that we understand exactly what this term is by definition. And for this course, we'll define population as the entire group or collection of items you want to draw conclusions about. So another important term that we need to distinguish is sample. So sample and population, many people usually confuse them, but a sample, it is a subset of population, meaning we are taking a small portion that will be representative of the entire population in order for us to make conclusion. So it's a smaller representative subset of the population to conduct the actual study. So let's go and have a look at more important terms, okay, others. So let's look at the term which is defined as a mean, okay. Others would call this mean, or others would remember this as average, okay. So what you need to remember is that when you're looking at the average, you're just looking at the sum of the scores. So let's assume that we are assessing scores, okay. So what you need to understand is that when we're talking of the mean or the average, all what we are talking about is simply if we normalize the data, what do we end up having? So what we are going to say is that for the average, let's just define it as the sum of all scores, okay? Whatever those scores are. And then we will divide this by the number of scores. Okay. And usually what you will see is that the mean is usually denoted by a certain sign. So it will usually be an X with that dash at the top. And this will always be equal to the sum of whatever data we're looking at, which is the sum of X. Those are the scores divided by N. Okay. Where N, you are talking about the number of scores or however many data points you have. Okay. And then what we also want to speak of when we are talking about important terms, we also want to talk about the maximum. Okay. If we are talking about score, this is the biggest, or we can say the largest score. Okay. So this will be our maximum. And then we will also have our minimum. And for this, you would be talking about your smallest score. Okay. So meaning you rearrange the data, you get the smallest score. And then we will talk also about, we spoke of the mean. Let's speak of the median. Okay. So whenever we're speaking of the median, this is a value that is at the center of the data. Okay. So this is the center score of the data. Okay. So this is the median. Now, how do we find the median? Well, what we are going to look at is this. So the median, which is also known as Q2, how we find it is we are going to say n plus 1 divided by 2, where n is the number of scores. So what I need you to note is that this is not really the median, but what we find here is actually the position, rather, of the median. Okay, where is it positioned? So what you will notice is that if we have n is odd, then what you will note is that your median, it will be at n plus 1 divided by 2. So you will get the position here of where your median is. And this is after rearranging your data in ascending order. But however, you will note that if n is even, then your median will be equal to the average of the two numbers. So it will be the average of the number on the left of the position that we get. Let's say you get 2.5, and the number which is on the right. So what do I mean by this? So let me give you an example. So let's say when we calculate n plus 1 over 2. So let's assume an n value, let's say of 10, okay? So this means we're going to have 10 plus 1 divided by 2, which is going to give you 5.5. So when you look at 5.5, you will see that it's less than 6 but greater than 5. So meaning if I rearrange my data, I'm going to take the value sitting at position number 5 plus the value sitting at position number 6 and divide it by 2. Okay? That is very important for you to understand. Right. Now, with that said, let's go ahead and have a look at percentiles. Okay? But maybe before we go to percentiles, let's have a look at another simple definition, which is the mode. So for the mode, we are talking about the score that occurs the most often. So by most often, all what we mean is that it occurs many times. So if you have a number that appears 5 times, but another one appears 6 times, the one that appears 6 times becomes our mode. Okay. And then what we need to speak of, it is quantiles. So let's have a look at quantiles. Not quantiles, but quartiles. So what you need to remember about quartiles is that we have 3 of them. Okay. So what we have is we have the quartile, which we call the first quartile. So we have the first quartile. And the first quartile is also known as the 25th percentile. Okay. We'll explore what this means later. And we have what we call the second quartile. So this one, we call it Q1. Okay. And then we have the second quartile. And this is what we call the 50% percentile. And this we will call Q2. And this here is also known as your median. Okay. And then let's go ahead and have a look at our third quartile. So we also have our third quartile. And this is also referred to as our 75th percentile. This we will commonly refer to as Q number 3. Okay. It will be Q number 3 or Q3. So now let's have a look at how do we find the positions. So if you look at Q1, it is going to be given by 1 over 4 into n plus 1. Remember, what we are getting here is the position. Need you to keep this in mind. Then Q2, it will be 2 over 4, which is just the same as half. So it is half of n plus 1. And remember, what we are getting here is the position of Q2. So once we rearrange the data, then that will be the position where Q2 is. Okay. And then we go to Q3, which will be 3 over 4 into n plus 1. And this, remember, it will tell us the position. And whenever a position is like 0.5, meaning in between two numbers, you take the number on the left and the number on the right, you add them and you divide by 2. Okay? Let's have a look at another important term, which is called range. So when you're looking at range, it's very simple. It will just be your maximum minus your minimum. So meaning after rearranging your data, you just take the maximum and you minus the minimum when they're looking for your range. Okay. Then we have something that we call interquartile range. So interquartile range is also known as IQR, and that is Q3 minus Q1. Okay. And then let's have a look at even more terms before we jump into questions. And another term that I need us to look at is what you call your standard deviation. In fact, before we even have a look at standard deviation, let's have a look at variance. And variance is usually given, I'll show you this, the sign when we start working, but the formula for variance is you'll have the sum with the actual data minusing the mean, and you square that, you sum all of those and you divide by n. Okay? And then you can get the standard deviation, therefore. So let's have a look at our standard deviation. And the standard deviation, if you look carefully, it's just the square root of your variance. Okay. So you'll have your variance like this, which means essentially our standard deviation, if I can just write that down here, paste that, it will just be equal to the square root of this here. Okay. Hope that you are able to make sense of what is happening. So that becomes your standard deviation. So with these terms out of the way, let's go and see if we can actually attempt to answer some of these questions and make sense of these concepts here. There's many more to cover, but let's go and have a look at examples. This is part 1. Okay. So let's have a look at what is happening here. So question 1, we are told Mr. Ngwane is the sales manager for a furniture shop. Every month, his 15 staff members report the number of customers who visited during the previous month. Okay. So the results are as follows. So you have 12, 15, 15, 19, 22, 26, 26, 32, 33, 33, 33, 33, 35, and 35. So what we are required to figure out is the median of the data. So remember, median is the middle value. Okay. So if, for example, let's take 1.1.1, quickly rewrite the data. So we have important checks that we need to always do before we start working. So what is important is ensure that the data is arranged from the smallest to the biggest. So in this case, if you observe carefully, that has been done. So I'm just quickly going to write down the numbers again. So what I need us to do next is and this is going to be our step number 2 whenever we're dealing with such a problem. We need to count how many sets do we have here. So if you do your counting, you'll see that what we have is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So you will realize that n equals 15. Okay. This is the sample number. Okay. So essentially, how many readings do we have? So that becomes our sample number, which is 15. Then remember, your median is the same as Q number 3. Okay. So, sorry, it is Q2. So your median is the same as Q2. But remember that for Q2, the position we find by saying n plus 1 divided by 2, which means we say 15, plus 1 over 2, and we get number 8. Okay, so you'll see that we get that number 8 there. But what you need to remember is that this 8 here tells us the position where, after rearranging the data, we are going to be able to read the median. So let's quickly copy this, paste it here, and then go and read our median. So I'm going to zoom in, and what you'll see is that we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No. Why am I now reading so many numbers? Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what you should be able to see is that at 8, position number 8, that is what we get. Okay, so this means that our median for this data is 32, okay, which is sitting at position number 8. Okay, and then 1.1.2, interquartile range. So they're looking for I, Q, R. And if you remember that we said it's Q3 minus Q1, okay? Now the question should be, what is Q3? And also, what is Q1 in order for us to find this? So let's go ahead and look at the positions. Okay, so we remember that Q3 is the same as 3 over 4 into n plus 1, which means we have 3 over 4 into 15 plus 1, like that. So if you do the division there, you will see that what we get is, what we end up getting is 12, okay? So now if you go to position number 12, you will see that what we end up getting, as I'm highlighting, is 33, okay? So our Q3 will therefore be 33. Then let's go and have a look at Q1, but here we're still looking at the position, and we know Q1 is the same as 1 over 4 n plus 1, which is 1 over 4 into 15 plus 1. And when you go to your calculator and punch this, what you will end up getting is 4, okay? Remember, this 4 here is the position, okay, where our Q1 is. So now I can go and find my Q1 to be equal to, so we have 4. So if you observe carefully, you will see that at position number 4, we have 19, okay? So, sorry, yeah, at position 4, we have 19. So Q1 equals 19. So therefore, our IQR, which is Q3 minus Q1, that will be, we found 33. So we have 33 minus 19. So let's go ahead and punch that. And if you do 33 minus 19, what you end up getting is 14, okay? And this becomes your IQR, interquartile range. Okay, very important, guys, and I hope you understand. Let's have a look at 11 at 1 point, not 11, 1.1.3. So they're looking for the mean, okay, which is usually denoted by X with a dash there. So for the mean, what you do is you sum all this data and then you divide it by n. Okay, what do I mean? Well, if we take this entire data, we put it here. So we'll be calculating our mean. So that mean is going to be, all what we need to do is to just sum this data. So you have a plus, a plus, a plus, plus. And then after doing our summation, we need to ensure that we divide by n, which our n, it is 15. So I'm going to go to my calculator and punch this as is. So if you use your calculator carefully, you will see that the mean, we end up getting 26.6. Okay, that is what we end up finding as our mean. And then let's go ahead and have a look at 14 at 1.1.4. Okay. And 1.1.4 focuses on standard deviation. Okay. And remember, according to what we learned here, is that standard deviation is given by this here, where we need to do x minus our mean, and then we square that. Okay. And for that, I'm going to make a table. Okay. So let's go ahead. I'm going to take the data as is, and then we are going to go to the next page and we make a table. So this data here, remember, it represents your x. Okay. So this is all of your x, and then your mean we found is 26.6. So here's what we are going to do. So we're going to have x here, and then we are going to have your mean. Then we are going to have x minus your mean, and then we are going to have x minus your mean, and this will be all squared. Okay. And yeah, let's go ahead and have a look at this. So if you look at the data, you'll see that we have a 12, we have a 15, 15, 19. Let me populate. So the columns for the actual data and the mean have been populated. So next we are going to do x minus the mean. So essentially it's going to be 12 minus 26.6. And if you observe the answer, it's going to be negative 14.6. Okay. And then we go ahead, we do the next one, which is going to be 15 minus 26.6, and that is going to be negative 11.6. You'll have negative 11.6, and this carries on down. So I'll populate this. So what is next is for us to square the value which we find here. So if you observe carefully, if we take 14.6, or rather negative 14.6, and you square it, you will see, I'll round off this to 2 decimal places, you'll get 213. You'll get 213.16. Sorry, 0.16. Then if we go for the next item, which is 11.6, it's negative. You square that, what you will end up getting is 134.56, and you'll see you'll get 134.56. And this will carry on down. We just square what we see here, we put it on the other side. Okay, so that has been populated, guys. So what I need you to remember is they need us to calculate our standard deviation. And if you remember, our standard deviation is given by the summation of x minus our mean, and then all divided by n. Okay, so that is what our standard deviation is. So what we can do is we can look for the sum, okay, by looking at these here. And if you observe carefully, you will see that the sum that we actually get here would be this element here. Okay, so if we look at what we are going to get there, I'm going to get the sum of x minus x all squared. If I sum up all the values that I have there, which is your 213.16 up until 70.56. So let's find the sum. So the sum that we end up finding here is 948.6. Okay. So this means we are now ready to calculate our standard deviation, which is SD. So our standard deviation will simply be the square root of the number we just found, which is 948.6, and this will be divided by 15. So let's go ahead and have a look at our SD. So this is going to be square root of that answer divided by 15, and our standard deviation is 7.0. 0.95. Okay, so that is what we end up getting. So I hope that you guys were able to understand question 1. And this brings me to something that I want to also introduce you to, which is something that you should have learned a while back. They call it the whisker diagram. Okay, so let's have a look at that before we go to the next question. So we have what we call a whisker diagram. Other people call it a box and whisker diagram. So let's call it that. Let's also call it a box and whisker diagram. So essentially what is happening there is you'll have a box, which is such as this one. And what you'll have is you'll have a line, another line on the other side, and you'll have a line like that, and another line like that. And we'll have some line here inside the box, okay? So now what is very important is exactly what these lines stand for. So here, what we put in is our minimum. So whenever they say draw the box and whisker diagram, you put in your minimum value of the data. And then here, what we do is we put in our maximum. Okay. And then what you need to remember at this point, that is where we are sitting at our Q3, while at this point, that is where we're sitting at our Q1. And here, we're sitting at our Q2, which you also know as the median. Okay. So this is what is going on this box. Okay. So what you need to note is that we have 3 types of these boxes. We have one which is negatively skewed, one which is positively skewed, and one which is not skewed, which is symmetrical. Okay. So let's start and have a look at the one which is positively skewed. Okay, so when they say positively skewed, the kind of box and whisker which we're looking at is something like this. So you'll have your box and have the other end. Right. And what you will notice is that where your Q2 is at, it will lean more on the left. Okay. So what you will see is that there's a lot, the skewness is on the positive side because we know that we have the median there. Okay. But when does this happen? Such that this line here shifts more to the left. If you observe carefully, this here happens whenever your median is less than your mean. So this here happens when your median is less than your mean. Okay. So think of it this way. And then we obviously have another one, which is negatively skewed. Okay. So meaning more data sits on the left of your median. What does that mean? Well, it means this. If we draw our box and combine that and that. So what will happen is if it's negatively skewed, it means more of your data will sit on the left of the mean, of the median. So if you observe carefully, that is what is happening here. And when does this happen? Well, this will happen whenever your mean or whenever your median is greater than your mean. So if your median, which is Q2, is greater than your mean, this is when this happens. Okay. And we'll exploit and draw it for the problem that we're working on. And then we obviously have a problem where it it's just symmetrical. Things are looking balanced and nice. Okay. Where we can have our median here. And if you observe carefully, you'll see that the data here is not skewed on either direction. Okay. So you will see that this one here, we'll just say it is symmetrical. And when does this happen? This happens when your mean and your median are equal. Okay. So I hope that you guys understand. Now with this in mind, let's go and have a look at how we can draw our box and whisker for that previous problem. Okay. So let's go. So you will realize that we have our Q1 and Q2. And the first thing that I'm going to do to be able to figure out the skewedness is to look at our mean, which is Q2. So Q2, the median, is 32. Okay. But the mean, we found it to be 26. So if you look carefully, our median is greater than our mean. So let's quickly go and check. We said when the median is greater than the mean, this becomes negatively skewed. When the median is bigger than the mean. So meaning the line shifts more to the right, this mean here. And you have more data to the left of your median. Okay. So let's go ahead now that you know. So it means if we were to draw the box and whisker for this one, it is negatively skewed. Okay. So let's go ahead and try it out. So let's have a look at our box and whisker. So what is usually easy to do when you are doing these is to quickly have a small scale, at the bottom. So let's have the scale here. And on the scale, we are just going to put in numbers, okay? That will assist us to be able to keep track of where things are at. And what I'm going to do is I'm going to use, let me see, from 12 to 35. So what we can use is we can use maybe scales of 5, say. So what I'm going to do is I have 12. So I'm going to have a 10. Then let's put 15. Then let's put 20. Let's put 25. Let's put 30 somewhere there. 35. Let's put 40 there. Okay. So that is a good enough, 1. And then remember that we need our minimum. So our minimum is at 12. So 12 is somewhere here. So I'm going to draw that line to be like that because that's our minimum. And then you remember your Q1. So let's go and look at your Q1. Your Q1 is at 3. Sorry, where's our Q1? Q1 is at 19. Okay. So that is just before 20. So we are going to have our Q1. Okay. So our box will start there. And then let's go and have a look at our Q3, which is where the box ends. Our Q3 is at 33. So that's just before 35. So somewhere there. So let's quickly have our box. So our box is something like that. Okay. Let's erase these pieces here. So that is our box, and let me have this line here. Okay. And then let's have a look at the maximum. So the maximum value is the last one, which is 35. So we should have a line here. So let me make it straight, put in a line, and we can erase. Okay. So that's our 35. So all what we need to do So just connect now. Connect. So we already know that this is going to be negatively skewed. What does it mean? It means you'll have a much more bigger gap to the left. Okay. But what we can do is we can go and look for the median. So our median we found is 26.6. So if you go and you look carefully, 26.6 should be right about here. Okay, so if you observe carefully, we can put in our line here. So that is that. Okay, so what you will see, you'll see that the portion that is on the left is a bit bigger. Okay, so if you observe carefully and you draw everything according to scale, so that is what we should have. So here you should have a value that is 12, and then here you should have 19. My apologies. Remember, we're putting the median, not mean. So my mistake. Where is the median? 32. So very silly mistake there. 32. So remember, we're putting the median. So 32 is somewhere here. So you can clearly see that this is negatively skewed. Look at how big this side is. Okay. So you can see, as per our note, that this here is negatively skewed. So you will see that it is negatively skewed because you have more data to the left of the median, of which our median is Q2. So let's quickly note this will be 12, and our Q1, we found that to be 19. So we have a 19 here. And then for our median, we have a 32. So you have 32, and then your Q3, that is 33. And then your maximum, that's 35. And the teacher will be so proud of you. Okay, I hope that you understand. If you do, let's go and have a look at the next question. Okay, guys, let's have a read. Let's have a read of this question. Let's read. So question 2 reads, a school held a sports day. One of the items on the program was an obstacle race. Teams of 10 parents and learners participated in the race. The table below shows the time taken in minutes by each member of a particular team to complete the race. So the first question, 3.1, okay, mind not that, I just labeled it as question 2. The first question is, how long in minutes did it take for the fastest member of this team to complete the race? Okay, so remember that this is time. So fastest would be the smallest time. Okay, so that you need to think of here, that fastest means the smallest time taken. Okay, and if you look carefully, the person who took the shortest time is the one who took 4. And remember, this is in minutes. Okay, so that's 4 minutes. So 4 min. Okay, so let's have a look at 3.2. This was an easy one. Determine the mean time taken by this team. So let's have a look at the mean. So remember, the mean, which is equal to x, you will take the data and sum it and then divide it by divided by the number of points you have. So if you observe carefully, we have a 4, 12, 13, 16, 17, 18, 20, 22, 22, and 25. So if you quickly count for us to find n, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n is 10, and it was in part already given. Okay, so our mean then, x will simply be So we'll take the data which we have here and just sum it and then divide it by n. Okay. So let's go ahead and sum this. So I'm just going to put a plus plus. And then, well, are we missing any? Yes. So plus, and then we're just going to divide by 10. Okay. So I'm quickly going to use my calculator on the side in order for us to compute this. So the x, or the mean that I end up getting, is 16.9. Okay, so it's 16.9 minutes. What does it mean? It means when we average the minutes taken, it's 16.9. Okay, so this is the mean time. (16.9 minutes). So let's have a look at 3.3. We are required to calculate the standard deviation of the data. Okay, so remember how we calculate your standard deviation. So what we will need is we'll need x. So we're now looking for standard deviation. We're looking for standard deviation, which is SD. So remember, your standard deviation, SD, is given by the square root of the summation of x minus the mean, all squared, divided by n. Okay, so what I'm going to do is I'm going to have x, then I'm going to have the mean. So for the x, we just put the data as it is for 12, 13, 16, then 17, 18, 20, 22, 22, and 25. And then we'll have the mean, which is what? We found it above, 16.9, 16.9, 16.9, 16.9, 16.9. And then next, what we are going to have is we are going to subtract the 2, okay? The x minus the 16.9. So we're going to do 4 minus 16.9. And what we end up getting is negative 12.9, okay? And then you go to the next one, where you are now doing 12 minus 16.9, which gives you negative 4.9. We do the same for the rest. And then what we now need to do next is do x minus the mean all squared. Okay, so essentially what I'm doing is I'm taking the value that is here and I'm squaring it. Okay, so if you go ahead and take negative 12.9 and you square it, you will see that you will get 166.41. Okay, then you go to the next one, you take negative 4.9, you square it, you will see you'll get 24.01. Okay, then you go to the next one, you take negative 3.9, you square that, you will see that you will end up getting 15.21. Okay, and you carry on and do the same. So if you observe carefully, we are done now. So essentially the sum that we have here, it's just the sum of x minus x dash, and this is squared. So this becomes the sum that we'll just take there. So I'm going to go and say 166.14.41, sorry, plus that 24.01 plus, and the rest of the term until we get here. And this will give me what this sigma notation is for, so that we go and plug it there. Okay. So what we end up getting is the answer is 334. So we get 334.9. Okay. So you can go ahead and confirm this. So that means our standard deviation is going to be the square root of 334.9 16.9, and this is divided by 10. So let's go to our calculator. It's going to be the answer divided by 10, okay, for my case. And the answer we end up getting is 5.79, okay, minutes. So this becomes our standard deviation. So let's go ahead and have a look at the next question, which is question number 3.4. So 3.4 reads, how many members of the team completed the obstacle race outside 2 standard deviations of the mean? Okay. So this question is very important for us to understand. So when they say outside 2 standard deviations, we need to understand we need to have 2 boundaries. You will always have an upper bound, and your upper bound is given by your mean plus they see 2 standard deviations. So it will be 2 times your standard deviation. Okay, so 2 times our standard deviation. That's our upper bound. But what you should notice is that we have a plus here. Okay, and then we go for our lower bound. So that what we are going to do is we are going to count the members, the team members that had scores that are going to be between what we found here. So we're going to say the mean minus 2 standard deviations. So it will be minus 2 times our standard deviation. So essentially that. Okay. What is very important to highlight is have a look at the sign, negative. Okay. So if you remember, you should remember that our mean is, let's go and check. So we found our mean is 16.9. So we found 16.9 minutes. And then for our standard deviation, we found 5.79. Okay. So our standard deviation is 5.79. So let's go ahead and look at our upper boundary. So on the upper side, what we are going to have is 16.9 plus 2 times 5.79. And this is going to be, let's use our calculator, 16.9 plus 2 times 5.79. So this gives us 28.48 minutes. Okay. Now let's go for our lower. So for our lower, we'll take our mean minus 2 times 5.79. So let's just put a minus. And the reason why we have a 2 is because the question says within 2 standard deviations. Okay. So the 2 there is exactly that. Okay. So what we are going to end up finding is 5.32. Okay. So what we want to do is to now count the numbers. Let's say we should count the numbers between these 2 values. So between 5.32 and the upper bound 28.48 minutes. And this here will tell us how many members. Okay, so let's take this here, copy, and put it up here. Okay, so if you observe carefully, you'll see it must be greater than 5. So we will see that we have a couple of them. So this will be included, but less than 28. Well, this will be included, this. 28 is still, available there. So we're going to have that. Okay, also. So essentially we have 9 of the members that are within 2 standard deviation of mean. Okay, so the answer is that 9 of the members are within 2 standard deviations of the mean. So this here becomes our answer for this question that we were looking at. That is question 3.4. Okay. Then 3.5 we are told, and this I think I might leave as your homework. It took another team member a total of x plus 5 minutes to complete the race, where what we need to do is to calculate the value of x if the overall mean of the two teams combined was 18 minutes. So let's think carefully of this last question here. So we are told that it took a team member x plus 5 minutes to complete the race. We should calculate x if the overall mean of the two teams was 18. So think of it carefully. It's a very simple question. So 3.5, it means we had one team that took X amount of time, and we had another team, let's call it team A and B, that took X plus 1. So this is team A. Team B took X plus 5. And we are told that the mean is 18 minutes. So we are required to calculate, what the x will be. So if you think carefully, you'll have x plus 5 plus x, we have two teams, divided by 2, and this should be 18. So this will be 2x plus 5 divided by 2, that equals 18, multiplied by 2 both sides. So let's just let's multiply by 2, but maybe let me move that, put it here. Okay. So you'll see that what we want to do is to quickly multiply by 2, multiply by 2. Okay. So if we do that multiplication, you will see that what we end up getting is your 2x plus 5, that will be equal to 36. Okay. Then we can transpose the 5, and you'll see that 2x will be 31. Then we can divide by 2 both sides, and you will see that 31 divided by 2, that should be 15.5. Okay, so therefore the value of x will be 15.5 minutes. Okay, so I hope that you guys understand. Let's have a look at the next question then, which is this one, question number 3. So for question 3, we are told a coffee shop counts the number of cappuccinos that they sell on any day for 2 weeks. These are the results. Draw the box and whisker for the above example. Okay. So remember, for our box and whisker, we need to first rearrange the data. Okay, so I'll put in some steps here. Step 1. So what we are going to do is arrange the data in ascending order. So let's go ahead, smallest to biggest. So if you observe carefully, you should have a 10 and then 11. And if you observe carefully, you'll have a 39. Sorry, you have a 34. And then you have a 39. And then you have a 41. And then you have a 44. Okay, so step number 1 is done. We have rearranged the data into its ascending order, meaning from smallest to biggest. And now what we are going to do is to go to step number 2, where we want to figure out what is n. Okay, So if you observe carefully, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So n equals 14, so 2 weeks. Okay. And then now step number 3, what we want to do is to figure out what is the mean and the max. Okay. That is very easy. So if you observe carefully, the mean becomes the first term, which is 10. So meaning in one of the days, they could only sell 10 coffees. And if you look at the maximum, it's the last number, that is 99. So in one of the days, they were able to sell 99 cappuccinos. Okay. Then step number 4, remember, as part of our box and whisker, we actually need our Q1, Q2. Okay. So let's have a look at Q1, Q2, and Q3. So we'll end with the mean, which will tell us how skewed our data is. So remember, Q1 is given by, you have 1 over 4 into n plus 1. So that is essentially the position, okay? So you have 1 over 4 into, we have 14, so you have 14 plus 1 equals, so let's quickly get our calculator. So we'll have 1 over 4 into 14 plus 1, which is 15. And then this becomes 3.75, okay? So that's the position of Q1. Now let's go to Q2. So with Q2, we have half of n plus 1, which is going to be half of 14 plus 1, which is going to be 1 over 2 times 14 plus 1, that's going to be 7.5. Okay, so that is what we have. Then we can go to Q3, still looking for our position. So we have n plus 1, that is going to be 3 over 4 into 14 plus 1. This is going to be, let's have a look, 3 over 4, 14 plus 1. That is going to give us 11.25. Okay. So remember that what we were doing is we're actually working on the positions. So now let's have a look at the actual values. Okay. So if we can start with Q2, which we found to be at 7.5. What this means is that Q2 is between, if you observe carefully, position 7 and 8. That is what it means. So it means that our actual Q2 will be, so let's go and figure out what is at 7. So this is 1. Well, maybe let me copy this to here. Okay. Let's erase this up here. And let's move with this. Okay. So what we are going to have is the following. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So if you observe carefully with Q2, Q2 will just be, so we'll add the 2, which is position 7 and 8, and then multiply by what we see there. Okay. So position 7 and 8, if you observe carefully, that is 56 plus 68. And this is divided by 2. So the answer ends up being, because it's going to be in the middle. So 7.5 is sitting there. Okay. So that is why we're just going to sum the 2. So we're going to have 56 plus 68. And this is divided by 2. And the answer we get is 62. Okay, so let's now have a look at your Q1, guys. So if you look at where our median is, our Q2, you will see that what we end up having is the data, which is, if you look carefully, you have 1, 1, 2, 2, 3, 3, and this then leaves you with that as your Q. Okay, so your Q3 then becomes your 3, 9. So Q3 becomes 3, 9. And then let's have a look at the next one, which is your Q number. My apologies, this is supposed to be Q1. Sorry guys. Let's have a look at Q number 3, which is, we look on the right of the mean. Okay, so if you look carefully, you have 1 and 1, and then 2, 2, and then you do your 3, you will see the middle term becomes that 77. Okay, so your Q3 is therefore 77. Okay, this is good because it just splits equally if you look at where your mean then becomes. Okay, so now that we have this, what we need to just figure out is our mean. Okay, so because our mean is going to tell us, is this going to be skewed to the left or is it going to be skewed to the right? So let's have a look at our mean, which is just that x. So it will just be the sum of the data divided by n. Okay, so let's go ahead and see what we do get. So we know that we have 14 days. So what I'm going to do is to quickly sum up that numerator there. So if you sum this up, you will see that the answer you will get will be 803. Okay, and if you do the division 803, just double check, divided by 14, what you end up getting is 57.36. 57.36. Now, if you observe carefully, let's have a look at our mean in relation to our median. Okay, so remember Q2, that speaks to your median. So our Q2 is 62. So you will see that your median is greater than your mean. So if you think of what this means, is that your median is on the right of the mean. Okay, what does it mean? It means your mean is on the left. So therefore this will be your mean is on the left. This will be negatively skewed. Okay, this data here will be negatively skewed. Okay, just remember the notes that you should have made earlier. So let's go ahead and try and sketch this. Okay, so we are going to have something that is like a number line kind of thing, right? And our numbers, we have from 10. So if you observe carefully, we have 10 up until 99. So what I'm going to do, just going to say we have a 10, we have a 20, 30, a 40, then 50, 60, 70, 80, 90, and then 100. Okay, something like this. Then now I'm just going to need to remember where the mean is at, where the max is at, and this will fall into place. Okay, so remember the mean is at 10. Okay, so at 10, I'm going to make a dashed line. And then our Q1, it is at 39. Okay, which is very close to 40. So just before 40, that becomes our Q1. Then our Q3 is at 77, so that is just before 80. So 77, somewhere there. That's your Q3. And your maximum is at 99. Okay. That's just before 100. Just going to draw a line. Then now what I'm going to look for is our median. So our median is 62. So that's just after 60. So somewhere here. Okay. So let's have our box. So our box, remember this is Q1. So your box will be sitting like this. Okay. And then you will see that your median will be somewhere here. And your Q1 somewhere there. No, your mean and your max somewhere there. Okay. Then I can now erase these. Right. Then now we can simply connect your box. So you have that and you have that. And if you observe carefully, you should be able to see it is skewed to the left. So you have more space to the left. Okay. And that is what I noted here. Okay. Because your median is greater than your mean, it will be skewed to the left. So that is what they were expecting you to be able to do. So here we're at 10. Here I think it's 39. Then here it's 62. Then here I think it was 77. Then here it's 99. Okay, that is what you were supposed to do. So let's have a look at the next question, which is this question here. So let's read the question. So the question reads, Bob collects two different sets of data about the number of times girls go to movies in a year and the number of times boys go to movies in a year. So here's the information that Bob collected. Okay. And then we are required to give the 5-number summary. So when they say 5-number summary, guys, once they say 5-number summary, all what they are saying is that you need to draw your box and whisker. Essentially what we've been doing. Okay, so let's start with girls. Ladies first. So what I'm going to do is to quickly rearrange that data first. Okay, so we'll start with the 5, if you observe carefully. Then we follow with a 9. And then we follow with a 12. Then there's a 13. And then there's 14. And then if you observe carefully, there's another 14, then a 21, 28, 29, and 3, 2. Okay, so we said we are going to focus on girls first. So with the girls, you should be able to see that we have our n being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10. So n becomes 10. So if you look at the minimum, you will see that it is 5. And if you look at the maximum, the last number, that will be 32. Okay. So now what we can do is to quickly find our Q2. So the position of Q2 will simply be given by half of n plus 1, which is going to be half of 10 plus 1. And if you do the calculation, you'll get 5.5. So where is that? So let me quickly position it. So 5.5, if we quickly number these, you'll see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 5.5 is in between here. So that is where 5.5 is sitting. So this means in order for us to get our Q2, we just need to add the two numbers, 14 plus 14 divided by 2, and that will give us 14. Okay. So that is what we end up getting. But now, if you think carefully, if your Q Q2 is there, then it splits this into even parts. So it makes this here to be your Q1. So therefore, our Q1 will be 12. Then let's go for your Q2. So you'll see how this is going to split. This for that, this for that, and you have a middle term. That becomes your Q number 3. So your Q3 becomes, if you observe carefully, 28. Okay. So you now have your Q1, your Q2, your Q3, and so on. So what we can do in order for us to finalize this, we can quickly figure out the mean, but we really don't need to. Okay. So let's go ahead and deal with this one. So I'm trying to think if I actually need to draw this on the same. Yeah, let's do so. So let's quickly have one for girls, and we'll combine it with the boys one once we're done. So for girls, this will be our box and whisker. Okay. So let's have a look at the numbers. So we have 1, 2, 3, 5, 2, 32. So we can just jump in steps of, let me think. Yeah, I think let's use steps of 5. That should be okay. So we're going to have a 5, 10, 15, 20, 25, 30, and then 3, 5. Okay. Now let's go ahead and plot girls. So the minimum is at 5. Okay. And then Q1 is at 12. So that is just after 10, but before 15. So let's put our 12 to be somewhere there. And then our Q3 is at 28. So that's just before 30. Okay, so let's put a line there like that. Right? And let's go for the maximum. So the maximum is 32. So our maximum is somewhere here. Okay, so we're ready to draw our box. So our box will be something like this. Okay, and we have that. And then we have this here. Right. Then let's go and quickly note down our Q2, which is at 14. So 14 is just below 15. So or 14 is somewhere here. So let's put in this with a different color. Right. So that is how this is skewed. Okay. And remember, this is for the girls. So we're looking at girls. So let's go ahead and have a look at boys. So for boys, I also quickly need to rearrange this thing. So for boys, let's rearrange their, scoring on the number of movies they watch. So if you observe carefully for boys, you'll see that we will end up with a 1, 14, 14, and then 15, 18, 23, 24, 28, 29, and 30. So let's make some space. 29 and 30. Okay. So that is what we end up getting for boys. So let's quickly figure out what is happening. So if you observe carefully, let me quickly label this. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the number n is the same. So n is 10, so which means your Q1, your Q2 will be at position 5.5, which is just sitting here. Okay, that is your 5.5. which means your Q2 will simply be the sum 18 plus 23 divided by 2. So your Q2 will actually be, let me quickly use my calculator. So 18 plus 23 divided by 2, that is 20.5. Okay, then we can go and read Q1. So you have this and that, this and that. So our Q1 is 14. Okay, Q1 equals 14. Then Q2, you will see you'll have this and that, this and that. So it will be 28. Okay, so your Q3 equals 28. Okay, and let's have a look at our mean. So if you look at the mean for boys, it is 1, and max for boys is 30. Okay, so now what I'm going to do is to just take the very same number line which I was using for the ladies and put it up for the boys. So let's quickly get the stats for the boys. It's these ones here. So it's very important that you guys are able to do all of what we are doing here. Okay, it's very important. So let's go ahead and have a look at Q1. So Q1 is 14. So 14 is just before 15. Okay, somewhere here. And then your Q number 2, that is 20.5. So that's just after 20. Okay, then your Q number 3 is 28. So that's just before 30. Okay, and your maximum is at 30. So it's very close. And your minimum is at 1. So let's have a 0 here and have a 1 somewhere there. Okay, so let's go ahead. So you'll see that we're going to have our box being like this. Okay, then we have 1 here. No. Right. And then we have another line here. Sorry. We have another line here connecting to that. Right. Yeah. Then now you can just erase and make this to look a bit neat. Right. So this is what we have. Okay. And I hope that this does make sense. So what we can do is we can go and look at the combination. Okay, so this here is for the boys. Okay, so let's put this up. There's our median there. Right, so let's copy this and put it here. And then let's go and fetch the girls. There they are. Copy and, paste. This would be just in case they were looking for this on one axis. So for girls, minimum was 5. Yeah. So it would look something like that. And maximum was 3, 2. Yeah, that looks about correct. Yeah, so this is what would happen. Okay, so this one here would be boys. Right, so I hope that this does make sense. So if you look at the girls, you will clearly see that this is obviously skewed to the right, positively skewed. Okay, but let's have a look at the next question. So in fact here we've given our A and B because we've done the 5 number summary. So and we've also done the box and whisker. So this here is for A and B. Okay, so maybe let me clarify something. So whenever they are talking about your 5-number summary, so because I know it leads to the box and whisker, I usually confuse this, but they're speaking of your mean and then your max and then your median, which is Q2. Then they're talking about your Q1 and Q number 3. Okay, this is what your 5-number summary is. Okay, this is very important for you guys to be aware of. So you could have just given them that, then drawing your box and whisker from there was going to be easy. Okay, easy stuff. So anyway, let's continue. So let's go now and have a look at the next question, C. We need to describe the distribution of each data set. So let's have a look at C. So if you observe carefully, you'll see that for the girls, it is positively skewed. Okay, so that we can all clearly see. So for girls, if you look at the data, it is positively skewed. Okay, then what about the boys? So for the boys, it's not very obvious to see. So for the boys, it's not very easy to see, but here's what we can do in order for us to figure that out. So what you can do is you can compare, okay, the values which you get. So you can always do Q3 minus Q2 versus Q2 minus Q1. Okay. Now, if you look carefully for the girls, if we do Q3 minus Q2, let's have a look for the girls. Our Q3 is that, what is our Q2? 14. So for the girls, what we would have is 28 minus our Q2 is 14, which would be equal to 14. And this will be versus 14 minus our Q1, which is 12, which would be equal to. So if you observe carefully, you have 14 versus 2. So because this one here is bigger, which is the distance, if you think about it from here to there, then this one becomes a positively skewed. So someone else could use the mean, and yeah, you can calculate the mean here. Did we calculate it anywhere? No. Okay. And then now let's have a look at the boys. So for the boys, I'm going to do the same assessment. So I'm going to figure out what is Q3 minus Q2. Okay. Which is just the distance from here to here and how does it compare from that. To be able to see this bar here is closer to which side, the left or the right. So this will be versus Q2 minus Q1. Okay. So let's go ahead for the boys. So Q3 is 28. I hope I was not reading the girls as boys. Okay. But anyway, let's continue. So it's 28 minus, for the boys, we are minusing Q2, which is 20.5. And that will simply be, let's have a look. So you have 28 minus 20.5, and that becomes 7.5. And this will be versus 20.5 minus Q1. If you observe carefully, Q1 is 14, okay, which that is going to be, let's create some space. You have 20.5 minus 14 and that becomes 6.5. And if you look at this, guys, according to it, you would easily conclude that this is going to be positively skewed. But with this approach, there's usually problems that one encounters. So these are both positively skewed. But what I want to do is let's have a look at this using the mean. So from the box and whisker for the girls, it was just pretty obvious. But what I'm going to do is I'm going to have a look at the mean. And this is for girls. Okay. So if you go and calculate the mean for girls, you'll see that it will become 17.7. Okay. And remember, your median for girls, we found it to be, where is Q2? 5.5. We found it to be 14. Okay. Now, if you observe carefully, you'll see that your median is less than, if you observe carefully, your mean. Okay. So it means your median is sitting on the left of the mean. So meaning data is skewed to the right. Okay. So this is positively skewed. Now, let's have a look at boys. So for boys, if you go ahead and calculate the mean, you will see that you will end up getting 20.6. Okay. Now, remember the median for boys. The median, which is Q2, that is 20.5. Okay. So if you observe carefully, you will see that our median, which is 20.5, this is less than your mean is 20.6. Yeah, it's less than your mean. Okay. So if you observe carefully, this is exactly the same thing. So your median is sitting on the left of the mean. So this means you get the same answer, which is positively skewed. Okay. So what happens is if you observe the previous method, it was giving us the same answer. Yeah, pretty much. But anyway, let's move on. And then that is just the description of what this is what they were looking for when they were saying description. So this here. And then now the question is, did more boys or more girls watch less than 14 movies? So let's think of what they are asking now. So if we look at our set here, if you look at our set, you will see. So let's have a look at this question here. So let me just take it to a clean page. Okay, let's have a look. So you will see that we are asked, did more boys or girls watch movies less than 14? So did more boys or girls watch less than 14 movies? So let's go ahead and figure out that from our data. So these are girls. So we'll look at 14 and below. So put that there. And let's go and fetch boys. So here's boys here. Okay. So if we look at the girls, you will see that they are saying 14 or less. So meaning we're looking at this here. So 14 or less, it is this batch here. So did they say less than 14? Okay, less than 14. So less than, it would be this one here. Okay. So this is the group of girls who watched less than 14 movies, and then less than 14 for boys. There's just one. Okay. So then let's think of our answer to this question. Did more boys or did more boys or more girls watch less than 14 movies? So between the two, which one is more? The ones who watch less than 14. And the answer, if you think about it carefully, it's very simple. We have more girls, because look here. So our answer to that question is we have more girls than boys. Okay, that's the simple effort. Then they ask, what percentage of girls watched between 14 and 28 movies, and what percentage of boys watched between 14 and 28 movies? Therefore, were there more girls that watched between 14 and 28 movies than boys, or vice versa? So this question here speaks to the percentile question. So we need to figure out, when we're looking at 14 for boys, what exactly are we looking at? So let's take this data set, both of them, and quickly do our analysis to figure out what's happening here. Okay. So delete and delete. So they're saying we should look at people who watched between 14 and 28. Okay, so let's go ahead and take 14 and 28 for girls. And for boys, let's go ahead and take 14 and 28. Okay, so we now need to figure out between the two which of these, watched more. So if you observe carefully, what we have here is we have one. Let me undo. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look at girls as an example, you will see that the grouping is made up of 1, 2, 3, 4. So you have 4 over 10. Okay. And this is times 100%. So that becomes 40%. So we have 40% of girls who watched between 14 and 28 movies. Now, let's have a look at boys. So with boys, what we are going to have is 1, 2, 3, 4, 5, 6. Okay. Well, I'm missing 114 here. So that makes it to be 7. So we have 7 over 10, then times 100%. So what we get is that 70% of boys watched between 14 and 28 movies. So now our answer here is that 70% of boys watched movies between 14 and 28, and 40% of girls watched between 14 and 28. Okay, so that becomes our answer, guys, for this question. I hope that it does make sense. So we looked at D and we looked at E. So let's have a look at D and then E on the next page. Okay, so done with that, guys. Now let's have a look at question number 5. Okay, so question number 5, we're looking at this below. So we are told below are 2 box and whisker diagrams for the geography marks of 2 different classes. Study them carefully before answering the questions that follow. Okay. So now we are being asked which class has the greater range of the marks. So what I need to remind you is what is range. So range, you should remember, it is the maximum value minus the minimum. Okay. So let's have a look at class 1. So class 1, because we're looking at range, I'm going to need to read the minimum. So if you look carefully for class 1, the minimum must be 28, while the maximum will be 91. So our range for class 1 will be 91 minus 28, which will be, let's quickly check, so that will be 63. That is class number 1. Okay. Now let's go to class number 2. So if you look at class number 2, you will see that the minimum is 14 and the maximum is 83. So the range of class number 2 will be 83 minus 14. Let's double check. So we have 83 minus 14, which becomes 69. Okay. Which class is the greater range of marks? So what we can do here is we can conclude. So conclusion, what you should be able to see is that it's class 2. Okay. So class 2 has a greater range of marks. Okay. So done with that, guys. Let's go and have a look at B. So in your opinion, which class did better in the test? And we should give a reason for the answer. Okay. So if you observe carefully, remember what the skewedness means. So if you look at the median, that talks to the middle, number. So let's look at these two carefully here. So if you observe this is skewed to, it is negatively skewed. So this is skewed to the left. Okay. So what this means is that you have more data, or your mean is on the left of your median. Okay. So meaning there's more learners who got less than 64 than there are learners who got, so there are more learners in the mean who got less than 64. So the mean is somewhere here. But then what this one means is that the mean is slightly bigger than your 56. So your mean is somewhere in the 50s here. So what I would opt for here is, when I look at this carefully, I would say class B performed better. So I would give it to class not B, class 2. So what we know, looking at how skewed this thing is that the mean is definitely bigger than 56. So meaning on average, learners got above 56. Okay, that is what we are picking up here. Then number C, someone else could, look at this differently and maybe conclude different. But yeah, if you do, share your thoughts. I'm really interested. So now we are asked, what is the interquartile range for each of the classes? Okay. So let's have a look at class A. So class 1. So remember, your interquartile range is simply your Q3 minus your Q2, your Q1. Okay. So now if you have a look at class 1, you'll see that your Q1, that is 37, and your Q3, that is 77. So your IQR, that is going to be 77 minus 37. And this should be, I believe, 40. Okay. So what we get is 40. So let's have a look at class 2. So at class 2, your IQR is still the same. So maybe let's write it, interquartile range. You get it by doing Q3 minus Q1. So you will see that your Q1 there is 43 and your Q3 is 74. Okay. Then your IQR will simply be 74 minus 43, and this becomes 31. Okay. So class 2, if you look carefully, our interquartile range, it is slightly smaller, okay, than this one here. So, and then the next question is, do you think the interquartile range gives a better indication of the spread of the data rather than the range? Okay, and then give a reason for your answer. So the first thing would be yes, it gives, that is what I would say, a better representation. Why? If you look at the range, look at the max and look at the mean, these are too far apart. So what it does is, if we focus on the two extremes, what we might be looking out for is outliers. So my reason here would be that the range is sensitive to outliers. Okay, that is the problem with this. So this is a very high achiever and this is a very struggling student. So if we use them, then what you end up getting is a value which is, a very big range. But if you use the center, you play around, or you use your interquartile range, that is more concentrated around your median, which is Q2. So that should give us a better average. So those are my thoughts, guys. I hope that you do understand all the work which we did here today. So please, I urge you to go and revise everything that we did. Make sure that you remember this skewed to the left, skewed to the right, symmetrical, and you remember all of this: standard deviation, your variance, your mode, your mean, and all the other fundamentals which we covered here. And remember, this is part 1. It is an introduction to stats of grade 12, but a revision of grade 11 statistics. Cheers, guys. I hope you enjoyed.